Hello students, so this is lecture number 6 of gravitation, and today in this video we will see what is gravitational field intensity. We will derive the formula of gravitational field intensity, and we will solve the questions based on this topic, right? Okay, so in this chapter we have studied that when two bodies of m1 m2 masses are placed at a distance r, will attract each other by a force which was governed by Newton's law, that is g m1 m2 by r square. Okay, see, first of all, what is gravitational field intensity? Suppose a mass capital M or a bigger mass is placed here, right? Okay, now if we are placing a unit mass, say unit mass 1 kilogram at this point, right, it will experience a gravitational pull towards this bigger mass. So this bigger mass is of 1000 kilogram, right? So this mass will experience a gravitational pull towards the bigger mass. Fine. Suppose the same mass, if I am placing over here, same mass, it will experience a pull towards m in this direction. If the same mass is placed over here, it will experience a pull this way. If I am placing it over here, it will experience a gravitational force in this direction. Same way if I am putting over here, this way, right? Okay, here. Now, the question that arises is how this mass is able to attract a unit mass which is at a distance, right? They cannot interact directly. There must be something, and because of which this unit mass is being attracted towards the bigger mass, right? So every body having some mass will produce a field. It will produce a field which is known as gravitational field. Any body having mass will produce gravitational field around it, right? This field will have some energy, this field will have some momentum. Because of this energy, it is able to attract another body. That means, suppose this is a mass of 1000 kilogram, a bigger mass, so it will produce a field around it. It will produce a field around it. This is the field which is produced by this mass this way. All in space, it will produce a field, right? And because of this field, if any another body is in the presence of the field produced by this body, that body will experience a force of attraction. Once again, when two masses, let this be m1, let this be m2. Suppose m1 is quite greater than m2, or you can say take m1 as 1000 kilogram, which we had already discussed, and m2 as 1 kilogram, right? Okay. So each and every body who is having some mass will produce a gravitational field around it. This field will have some energy, this field will have some momentum. Because of this energy, it is able to attract another body if another body is in the presence of the field produced by first body. Clear? That means now m2 gets attracted towards m1 because of the field, gravitational field, which is being produced around m1 in all the direction. Then the question may arise that m2 is also a mass. m2 will be producing its own field. m2 will be producing its own field. Yes, of course, but m2 is a test mass. m2 is known as test mass. It is to know, or it is to calculate, it is used for the calculation of the gravitational field produced by another mass. m2 is known as test mass. Test mass means very less mass, minimum mass. So that is why we have taken m2 as 1 kilogram, and we will here assume that m2 does not produce its own field because it is very less compared to m1. right? So now an M2 is placed just to calculate the effect produced by the gravitational field produced by M1. It is to calculate the effect produced by this M1, by the gravitational field which M1 is producing. Clear? Once again, M2 is a test mass, right? It gets attracted towards M1 because of the gravitational field produced by M1 all around the space, right? So what is gravitational field intensity? Gravitational field intensity is defined as, it is the force acting on a test mass because of the gravitational field produced around the mass, another mass. This is known as source mass. This is known as source mass, whose gravitational field is to be determined, right? So the force exerted on a unit mass by the source mass is known as gravitational field intensity, right? So gravitational field intensity I is defined as force acting on a unit mass. For us, unit mass is M2, right? So gravitational field intensity denoted by I, it is a vector quantity and is defined as the force acting on a unit mass because of the gravitational field produced by the source mass. Clear? And very specifically, with a purpose, we have taken M2 as 1 kilogram, right? Because less the mass, less will be the strength of the gravitational field, right? So we just wanted to calculate the effect of the gravitational field produced by M1. So we have taken M2 very less so that its own field can be neglected, right? So then we are able to calculate the gravitational field produced by this source mass or bigger mass. Clear? Right. Okay. So gravitational field intensity, but of course the mass, the test mass should be there, should be in presence of the gravitational field produced by source mass. If I am placing M2 at infinite, if M2 is at infinite, then since the distance is infinite, at infinite the gravitational field will be, the gravitational field intensity will be 0. That means M2 will not be affected by the gravitational field produced by M1, because as the distance increases, the gravitational field decreases, right? So at infinite, the gravitational field produced by M1 will not be there, will be 0. Right? Okay. So once again, what is gravitational field intensity? It is the force acting on a unit mass placed in the presence of the gravitational field produced by the source mass. Right? Suppose this mass, let M, which is unit mass, be placed at a distance, say r. Placed at a distance be r. Clear? Okay. So this distance is r. So what is the force acting on this mass, test mass? This is test mass. So the force acting on a test mass can be calculated with the help of gravitational law. Let this be M1. So G M1 equals to M. G M into, this is small m by r square. This is the force Gm1m2 by r square, right? Okay. So now what is gravitational field intensity? It is force acting on unit mass. Force acting on unit mass. So this should be, test mass should be 1 kilogram. So this will be Gm by r square into unit vector r. This unit vector is directed this way. The gravitational field is in this direction, so it will have a negative sign. This unit vector is directed this way. The gravitational field is in this direction. So both are opposite to each other. So we'll place a negative sign, or you can also say that since M is being attracted, so we'll place a negative sign. Right? Okay. So finally, the gravitational intensity at a distance r is I equals to minus gm by r square into unit vector. Once again, this unit vector, why is this negative sign? Because this was mass capital M, this was the position, right? So r vector is in this direction. There was a unit mass over here, and the gravitational field of this source mass is in this direction. Clear? So this r caret is to show the direction of position vector. Clear? Okay. Now, coming to the point, we can also write gravitational force as intensity into M. Exactly, this is what we will study in your 12th class, F equals to Q into E, where instead of gravitational field intensity, we will learn about electric field intensity. So once again, gravitational field intensity, first of all, what is gravitational field? Gravitational field means the effect produced by the mass, or any mass which will produce some effect around it. This effect is known as gravitational field, right? And gravitational field intensity is the force acting on a unit mass because of the gravitational field produced by the source mass. Clear? That is known as gravitational field intensity. This is how it is calculated. It is a vector quantity and it is directed towards the center of mass or center of gravity of the considered mass. Okay, now actually formula wise this is equals to acceleration due to gravity, right? It will have the same dimensions, same unit as that of acceleration due to gravity, but it should be clear to you that gravitational field intensity and acceleration due to gravity both are different quantities. Their formulas are same, their dimensional formulas are same, their units are same, but both represents different things, right? So gravitational field intensity is not equals to gravitation acceleration, right? Suppose there are two masses, say m1, right? Now I am not taking one as source mass and another as test mass. Let there be two masses, m1 and m2. Let the distance between them be d. Right? At any point P joining these two masses, the gravitational field intensity is 0. Let us say from M1 there is a, we will say the distance is x, where there is a point P where intensity of gravitation is 0, gravitational field intensity is 0. Okay, so this distance will be d minus x, right? Suppose we want to calculate this distance x, that from M1 at what distance the gravitational field intensity is 0. Okay, so the intensity, gravitational field intensity for M1 will be in this direction, for M2 it will be in this direction. So gravitational intensity at point P can be vector, will be the vector addition. So it will be I1 plus minus I2 because the directions are opposite. Okay, so intensity is 0 at point P. I1 it is minus gm1 by x square, right? Because gravitational field is minus gm by r square, and this will be plus gm2 upon d minus x the whole square. On solving this, we will have gm1 by x square equals to gm2 upon d minus x the whole square. G gets cancelled. So m1 by m2 is equals to x square upon d minus x the whole square. So it's finally x root of m1 by m2 equals to x upon d minus x, right? Cross multiplied, root m1 into d minus root m1 into x equals to root m2 into x. Root m1d equals to, take this term over this side, it will be root m1 plus root m2 into x. Therefore, x equals to root m1 into d upon root m1 plus root m2. Clear? This is how we will find the distance x at which the gravitational field intensity becomes 0. The resultant gravitational field intensity because of both the masses becomes 0. Clear? Okay, now along with this we'll understand in the next video that what is gravitational potential, right? And what are the gravitational potential for different shapes, like gravitational potential for sphere, spherical shell, ring, right? So we'll derive those formulas, and after completing the topic gravitational potential, we'll solve the questions which are based on intensity as well as gravitational potential.